easier ones. So we're going to start off with. Alright, so I have all of the general information up here at the top. So the general form of a quadratic in vertex form looks like this. It has parentheses with a little square on the outside of the parentheses. That's what defines a quadratic if you have an S squared there. So if you have an expression with parentheses being squares, that is going to be a quadratic. So we still have an A, H, and K the same way that we had that for absolute value. If you guys, I'll write this, but you guys don't have to. If you remember for absolute value, it looks like this. This is what our format for absolute value looks like. It's the same thing for quadratic, we just have parentheses squared instead of the absolute value. Okay? The vertex is going to be the exact same thing that we did last unit. Remember, to find the vertex of an absolute value, use this number and this number, but you write the opposite of the number on the inside. Same exact thing here. Okay? So we're going to use HK, but the H is going to be the opposite sign of what was inside of the parentheses. Our axis, which is our line that goes down the middle, I graphed that sometimes when we were doing absolute value. That's especially important for quadratic. It is important for absolute value, but we're going to emphasize a little bit more this unit. The axis is always x equals h. See how it goes through the vertex? Because it's a vertical line, it should be x equals, and because the value it goes through on the x-axis aligns with the vertex, you just use the x value from the vertex. And then instead of slope, we use this rule that I call the 1a, 3a, 5a rule. Because the sides are not straight, you can't use slope, because the slope is a repeated number that goes up, rise over run, and so it makes a straight line. When we have the curve, it kind of changes slope as we're going down. It has a particular slope here, then it gets steeper and steeper and steeper. So it doesn't have just one slope. It has a kind of extended slope pattern as you're going down the curve. So I'll explain how that works in just a second when we use the 1a, 3a, 5a. There are two steps that you guys are graphing. So again, finding the vertex. Same way that we did last unit, H is the opposite of what you would normally expect, and then K is exactly the same, and then you write them as a point. Again, if you guys don't see either of those things, they're 0, just like before. Yes, the parent function would be x, y equals x squared. So the parent function is always the function without a, h, or k. If you take all the extra numbers away and just write what's left over, it should just be a y and x, and then if there's a particular symbol, that would be included too. So just y equals x squared would be the parent function. There's no extra numbers. Okay. So once you guys have the vertex using h and k, we're going to use the 1a, 3a, 5a rule to create the sides of the curve. What this means is that whatever a is, which is the number at the very front, before with absolute values, we would consider that to be the slope. Whatever that is, you're going to multiply that times 1, times 3, and times 5. And then that's going to be your kind of incremental slope as you're going up. So for example, if a is a 1, it would just be 1, 3, 5, because 1 times anything is the same. So what you would do is you'd go up 1 over 1, up 3 over 1, and then up 5 over 1. So these numbers are basically just telling you how much you're going up between the points, so you always go up. Okay? So if we want to drop that down a little bit, I'm going to draw a little arrow and say always run 1, just to remind ourselves. But when you guys rise, you rise by whatever these numbers are. This is how it works with the slope. You rise by whatever 1a, 3a, 5a are, and then for the run, you always go over 1. Okay. So I have these two examples of the two different general shapes of the function. So this one has a smiley face. If your a is positive, it will always be going up. But if it's negative at the front, it will be facing down. That's your reflection over the x-axis. So I'm going to be referring to them as smiley faces and frowning faces because you have the smile or the frown. Frown rhymes with down. Yeah, okay. So if you have that negative in the front, that's your reflection. It would flip over the x-axis. All right, so let's review our transformations really quick, and then we'll jump into some examples. So transformations, I have your little key up here. So remember that whenever it's subtracting on the inside of the function, whether it's absolute value bars or parentheses, if you're reflecting on the inside of the function, you're going to be going right. If you're adding inside the function, you're going left. Remember, that's where you have to think opposite. That's why you normally take that. Then when you guys are subtracting outside of the function, so if it's at the very, very end where k is, if you subtract, you go down, if you add, you go up. And then we have our two different reflections, inside, outside, x versus y. We have our stretch and compress. So if the number that you're multiplying at the very front, your a, is greater than 1, that's a stretch. And if it's between 0 and 1, that's a compression. And then remember, if you guys see something like this, when you have a negative and a number, what do? They're two different things, right? The negative is separate from the 2. You don't see it as -2. You have to think the negative does something and the 2 does something. They're separate. So don't forget that detail. All right, so this is what an example will look like. We're missing the y-intercept and the zeros. So you might not have everything that we had in that list we did in the intro, but you be aware that you could be doing that. So just be prepared for anything. So for this first one, just looking at the function right here, can you guys tell me what the transformations are? I'm subtracting 1 on the inside. That's either left or right. It's going to be right. The rules work the same way. I know the function looks a little bit different, but it works the same way as we saw before. So -1 on the inside, just think opposite, so you would go right 1. And then what is -4 at the very end? Down 4. All right, so you have your transformation. And what would my vertex be? 1, -4. Works exactly the same as absolute value. You pull the number from the inside, change its sign. Pull the number from the outside, it doesn't change its sign. And then my axis, that line goes right down through the middle. It's really easy. You're going to start with x equal to the vertical. And then if it's going through the center, the vertex, what would the x value be? 1. So once you have the vertex, just copy over x equals 1. That's your axis of symmetry right through the center of the graph. Now we're going to graph it. So go ahead and draw a dot at 1, -4. Right there. And then off to the side, we're going to do our 1, A3, A5, A thing. Okay? So what is A? What's the number at the very front? 1. So I'm going to multiply 1 times 1, 3 times 1, and 5 times 1. So it's just 1, 3, and 5. Now, the way that you use the rule is very simple. Again, you're going to go up by each of these numbers and over 1. So our first one's going to be up 1 over 1. So we get here. Then our next point is going to be up 3. 1, 2, 3 over 1. And then from there, our next one's going to be up 5. 1, 2, 3, 4, 5 over 1. Like that. That's how you graph the side. Yes? And then once you have the right side, what did we do for the absolute value when we had the right side? Reflect it to the left side. Now you go up 1 and then to the left this time you go over. Up 3 over, up 5 over, and then you have your full curve. Okay? So these numbers generically start as 1, 3, and 5, but when your A is a different number, you have to multiply them by that number. So if like A was 2, it would be 2, 6, 10. You have to multiply them by whatever A is. But if it's just 1 at the front, it just is generic. Your kind of baseline is 1 through 5. Does everybody understand how to use that rule? Okay. All right, now that we have the picture, it'll help us get the rest of the blanks filled in. So what's the domain? All real numbers. So we're going to use Bell's notation. So I have negative infinity to positive infinity. And then what's our preferred way of writing the set builder? X equals all real numbers. This is an R with a double vertical line for the script part. Okay, what about the range? -4 with a bracket, positive infinity, and then how would I write the set builder? Y is greater than or equal to -4. Remember the equal to is there because it actually includes 4, -4. And it's greater than because I'm going up and above. All of my values are above -4. All right. What interval, now if you guys want to graph the axis, it might help with the increase, decrease, if you draw that line right down the middle. Alright, what is my interval of increase? Am I increasing on the left side of my graph or on the right side of my graph? On the right side. So what x value represents the start? 1, and then where does it stop? Okay, so from 1 to infinity, I'm increasing. And then the left side is my decreasing, which is from where to where? What's over here? Negative infinity until 1. So you guys will notice that your axis of symmetry, that axis goes right down the middle. That number that you use for the axis is what's going to go in the increase decreasing intervals. It's all connected. All right, do I have a maximum or a minimum? And where? Okay. Do you guys think there's a general rule about the maximum and the minimum? It's the same as the vertex. It'll always be the same as the vertex. All right, what are my x-intercepts? -1, 0, and 3, 0. Okay. And then my end behavior is x arrow plus x arrow negative infinity. Which side is that? Left. Where is it going to the left? And then x arrow positive infinity, the right side, is going also up towards positive infinity. Alright, everybody good with that one? Alright, go ahead and try the second one on your own. Alright, let's take a look at the second one. Anybody tell me what the transformations are? Alright, we have reflect over the x-axis, left 3, and up 2. Same system that we used before. Right, because the negative is at the front or outside of the parentheses, that's an x-axis reflection. Same as with the absolute value. Okay, what's the vertex? -3, 2, and what would my axis of symmetry line right down the middle be? Okay, so if we go over here to -3, 2, you can even draw a line of symmetry. 2, line of symmetry. Alright, now, remember that the way that we graph the sides is using the 1A, 3A, 5A rule. So what is A? -1. So if I multiply 1 times -1, and I multiply 3 times -1, and multiply 5 times -1. Okay, so that means that these are how much I rise, and then you always run 1. But if I'm rising -1, what does that really mean? You're going down, right? Whenever they represent slope as rise or run, you still need to know that sometimes you move down when you're working with slope. This incremental slope, you're going to go down 1 over 1 because it's negative, down 3 over 1, and then down 5 over 1. So you're slightly off the graph right now. Alright, so you start on the right side, and then you reflect that over the axis of symmetry to the left side. So you still go down 1 over 1, down 3 over 1, and then down 5 over 1. Right there. It's a weird line. Alright, so again, when you guys are graphing, how can you double check to make sure that your graph should be facing down versus up? Right. If there's a negative at the front, which tells you it reflects over the x-axis, so make sure you're double checking that. Alright, what's my domain? All real numbers, which you guys will write in both notations. Right? And then what's the range? Sure. If we only graph 1A, 3A, 5A, but it goes 1A, 3A, 5A, 7A, 9A, it keeps going, like all the other things. So We just graph 1, 3, 5 because that's usually all we can fit over there. But it will continue going to the right and to the left forever. We won't work with asymptotes again until like Alright, what's the range? Negative infinity to 2 bracket. Remember this is you read from the bottom up, so because this one starts at negative infinity, the negative infinity will appear first in the range. And then for the set builder, y such that less than or equal to 2. Because you're going below that number. Increasing. Because you're including 2. You can draw a dot at that first. Alright, negative infinity until negative 3.
Oh.
Use the axis as that line. Remember when we're doing increase decrease, it's all on the x-axis. So it's from over here until that line where it changes direction, and then from that line over. So increase is on the left from negative infinity to negative 3, and then I'm decreasing on the right side of the graph from negative 3 to positive. Maximum or minimum? At what point? This point is the vertex. Where are my x-intercepts? The 8 here. Negative 1. Oh, I just did drop it. Negative 1.5-ish. Maybe 4.5-ish, yeah. Approximate there. And then what's my end behavior on both sides? Negative infinity for going down on both sides. Cool. Alright, so that's vertex. Those 2 examples. Do you guys have any questions about how we go through that? It's very similar to absolute value. The only difference really is that slope will be the difference in how we approach that. Any questions? Alright, standard form is very different. Finding the vertex is different. The 1, 8, 3, 8, 5, it also applies. Just how you find the vertex is different because this is what your general form looks like. There are no more parentheses, so you can't do that like pull the inside and the outside number like we did for absolute value. We can't do it that way. So this is called standard form because you have the x squared and then the x and then the number without a variable. If they're in that order, all those 3 terms is a trinomial, then this is going to be in standard form. So vertex form has parentheses, standard form does not. That's really the easiest way to tell the difference. Okay. The vertex, we're going to be using this formula right here. You're going to want to circle or highlight that. That's how we're going to find the x value of the vertex is by using negative b over 2a. And then once we know what x is, to find the y, you just take the x that we just found and plug it into the function to figure out what y would be. Remember, x is the input, y is the output. So if you know what the input is, you can plug it in and get the output for y. So it's a little bit more intensive, takes a little bit more work to find that vertex. But once you have the vertex, you use the 1, 8, 3, 8, 5a rule the exact same way. The rest of the question is exactly the same as what we were just doing. The only difference, again, is finding that vertex. Slightly different. And then same thing, you have the smiley face of A. If there's no negative at the front, it's a smiley face. And then if there is a negative at the front, it's your kind of reflecting down over the axis. Now for this one, you guys can't find transformations until after you've graphed the function. I'm not going to be asking for transformations for this form of the graph. You can still find them, but only after you've graphed. So I'm not going to ask you guys for transformations for this one. Alright, so let's give this first example a shot. So we have this function right here. The best thing to do is now list out what A, B, and C are. They appear alphabetically in your function. So the very first coefficient is A, the second coefficient is B, and the third coefficient is C. So what's my first coefficient? Will the A be? Negative 1. You do not include the x, not the variable. Just A, B, and C are just the coefficients. Okay. What's the coefficient? B. Negative 2. And the C? Okay. So now that I know all those numbers, I can now plug them in. So to find x, we're going to use that little formula which you guys need to memorize, negative b over 2a. So what's b? It's negative 2. If you want the negative version of b, it's negative 2. Positive. Double negative becomes positive. And then 2 times a will be negative 2. It's 2 times negative 1. So that simplifies to 1. Sorry, negative 1. Simplifies to negative 1. So for our vertex, the x value is negative 1. Now how do I find the y? You're going to take the -1 that you have for x and you're going to plug it in. So I'm going to have this. Plug it into the function, the equation you get out. So because x is a negative, make sure you have parentheses when you're squaring it. So you're going to square -1 and then make it negative afterwards. So this becomes a +1. After you square it, it becomes negative there. So it's -1 plus 2 minus 5. What's -1 plus 2? What?
1 and minus 5.
Oh, plus 5. Square. What's -1 plus 2? Okay, and then plus 5. Once you guys do that, you have your. So again, the x comes from the -b over 2a, and then your y comes from plugging it in. Now from there, everything else is the same. Okay, what would my axis be? X equals -1. It's the same value as the x of your vertex. So we go from -1, 6, which is right at the top here. Our axis of symmetry going right down the middle, right there. And then we're going to do the 1a, 3a, 5a rule the exact same way. What's my a? Okay. And if I have the 1a, 3a, 5a rule, what's 1 times -1? 3 times -1. And 5 times -1. This is our incremental slope rule. So am I going to be going up or down?
Yeah.
Down. So I go down 1 over 1. Then from there I go down 3 over 1, and then from there I go down 5. 1, 2, 3. And then you repeat it on the left, the other side of the axis. So what would the domain be? Same as all the others, all real numbers. Okay. So you have both interval and set notation. What about the range? Okay, -infinity to 6. We're reading from the bottom up, so you start with -infinity and then end at 6. And then how would you write that in set notation? Less than or equal to? Below. Alright, then remember increase, decrease. That's going to start on one side of your graph, come up to the axis, and then from the axis to the other side of the graph. So am I increasing or decreasing on this side? The left side. Increasing. So where do I start increasing? -infinity. And then I stop at the axis. What number is the axis? -1. And then decreasing from where to where? -1. Alright, do I have a maximum or a minimum? Where? Okay. Where are my x-intercepts? -3.5-ish. 1.5-ish. Okay. And then our behavior. -infinity on both sides. I'm going to let you guys do the second one most under, but there's a catch at the beginning I want to talk about first and then let you guys finish it. So what would A, B, and C be for this one? A is 2. 0. Okay, how 0? Right. So you guys have to remember A is attached to the x squared. B is attached to the x and c is the number without a variable. If one of those is missing, it's 0. Okay, so because the x term is missing, that means that b is a 0. Okay, so I'll let you guys pick up from there. Remember to find the x value of the vertex, use negative b over 2a. Even if it's 0, you can still use it when you're plugging into that formula. Then once you find x, plug it back into the equation to find y. Alright, so go ahead and do the rest of the process, find all the information, graph it, fill out the chart, and then we'll move on. Yes? I can't scroll down. This is as far as I go. Questions? Sorry? It's 2 vertical lines and you draw the arrow. Other questions? This one with the 1a, 3a, 5a, because a was 2. 1 times 2, 3 times 2, 5 times 2. The 10 is too far off the graph, so you don't have to worry about that. But because a was 2 and you multiply 1 times 2, 3 times 2, 5 times 2, you get 2, 6, 10. So you go up 2 over 1, up 6 over 1. If you have 10, it's too far, so you don't have to do, like, way off the graph. Just do what fits. Alright? The axis is always going through the vertex, so it should match. And then the axis is what you use to do the increase-decrease, so that should match. They're all linked together. Alright, any questions about the vertex or the standard? Okay, so on the next page, there are 4 more examples. I am not going to tell you whether they are vertex or standard. You guys have to figure out yourself. So we're going to spend a little bit of time with you guys working on this independently or over the shoulder partner if you need a little bit of guidance or help. So I'm just going to give you guys, I'm going to put the answers on the board. Just going to write them up there. And then as you guys are going, you can check to make sure you're doing it correctly. So start working through those 4 examples independently or with a partner. And then I'll put the answers up in a second so you guys can check. Okay? So you have to check to see is it standard or vertex and then go with that process to graph it.